Hello, CIS40A. This is a video on Unit 13 lecture, which covers Chapter 14, 15, and 16. Some of these materials you will find on the final review and exam. Additionally, your Network Plus certification exam will require the knowledge of security and network monitoring and maintenance. So in Chapter 14, it mostly focuses on security principle for the network. And very much like the Security Plus, you have to know some of the basic form of attacks and also some of the threats that is coming into the network. The first area talks about social engineering, and in social engineering you would see that it breaks down to two areas. One is impersonation and the other is phishing attack. And social engineering just means that the attacker would compromise the network using tactics, trickery, and a lot of it would come in from email, phone calls, or in-person tricks. So the remedy for this would be regular training and awareness in the organization. Having the user awareness will help boost or reduce the risk of social engineering. The next area talks about network type of attacks. So eavesdropping is when they would use packet sniffing tools to analyze your network, and it would seek unencrypted information to evaluate your network packets. And through that, they would be able to gain information on access, such as credential. And the second type of attack would be spoofing. And in spoofing, there are three areas: MAC address spoofing, IP address spoofing, and email spoofing. So in MAC address spoofing, they would alter the source MAC address of the packet and use their own, so that way it would look like they would be a source type of address that's being sending through the traffic from your network. The second area would be IP spoofing, where they would alter the source IP address of the packet. And the third is email spoofing, in that they would alter the email address header or the email address information in the message. Another form of attack would be man-in-the-middle attack, and the attacker would intervene a conversation between the two systems that's being passed across the network, or from one network to another. This allows the attacker to view sensitive data between the two systems, and usually man-in-the-middle would be performed with another type of attack or other type of attacks. So when you would see hijacking, usually you would see man-in-the-middle being used with that, and that would be the next form of attack. In hijacking, the attacker would take over the session between the source and the destination using different tools. And it could be session hijacking, where they would take over the sessions, or in addition to other type of attack, you would see hijacking being performed, especially over the web. Denial of service attack is an attack that is performed using flooding or a lot of service requests, so that way the system cannot respond and it would crash. So there are different types of DOS. One would be the reflective DOS, in that the attacker sends traffic to the third-party system using IP spoofing to make the traffic appears to become victim's system. Second would be the amplified attack, in that the attacker would send messages of services and spoof the victim's IP address to generate a large amount of response. And this is what you would see in, if they are using ping, that would be Smurf. Smurf is a type of amplified attack. So instead of sending 4 or 6 requests, the amplified attack would have 600 requests from multiple systems to attempt the DDoS, or distributed denial of service, to one target server. So the distributed denial of service attack would be performing across multiple systems to be able to crash one server or one type of target. And by just sending continuous requests So the attacker can generate a large number of pings to a certain type of computer from you taking over other type of system using a malicious link where the user would click and become a zombie. And when a system becomes zombie, it would be taken over by the attacker system or the attacker to be able to control. Now, this type of attack is commonly being done to a larger enterprise or organization, but it can also be singled out with one target system. Now, in the difference between the distributed and the regular DOS, in that the distributed uses multiple type of systems to be able to perform the attack, whereas the DOS, you have a one-to-one type of attack. Buffer overflow is when the attacker sends more data to an application that's expected to gain administrative privilege to the system command line or shell. And this is taking advantage of the application's flaw in the design. So that way the attacker would be able to have higher privilege in the system, and that's being executed through the command line or shell. The next type of attack is an exploit, and in an exploit, the attacker will capitalize on the vulnerability of the software, and usually that can be from the way the software is designed, or a backdoor that was being installed in the software for administrative maintenance reasons, or other areas. So exploit would require some research from the attacker to be able to evaluate the type of vulnerability of that software, and a lot of times we would see this with Windows OS, and many of the exploit have been done with the prior version of Windows OS. Password attack is a way to crack passwords either on a network database or on the system, and to perform the password attack, the attacker would use dictionary attack, in that it would use dictionary-based word lists, or a brute force attack, which is tried and true type of attack, where it would guess all possible characters and try to plug them in. And so we can prevent dictionary attack and brute force attack by using account lockout policy for brute force, and also complex password policy for dictionary attack. And then sometimes you would see a hybrid attack, in that it would use word file and also placing numbers or characters at the end of the word, such as pass1 or something like that, where most users would use numbers and letters for their password. So in a hybrid attack, it would use a word file to guess the word, and also placing various characters or numbers at the end of the word. And so these are the three types of password attack. Then you have botnet, which is a group of systems that the hacker would take over to be used in the distributed denial of service attack. And there are many different botnets that exist today. And so if we were able to determine how these systems are taking advantage of the floods, and be able to target our network, you will have to use network monitoring tools and to also filter IP address and ports to be able to control that from your firewall. Next, we're going to talk about DNS poisoning, and the attacker would then alter the DNS data, which we've seen in DNS records. For DNS to resolve, you would have the A records or different type of records for lookup or even reverse lookup, in that in the DNS poisoning, the attacker would change or alter the DNS records to redirect the client to a different system. And then the attacker can also copy the DNS zone, whether it's primary zone or secondary zone, to be able to map out the network and see where else they would be able to explore or attempt to damage. Now, in the denial of service attack, you might have friendly or unintentional denial of service attack, in that someone can watch scenarios that can lead to unintentional attack. For example, the user cannot log on to an account and continue to try. And so that type of large request would then cause the denial of service attack from the authentication server and the web server. Then you also have a permanent denial of service attack, in that it would involve DOS being having permanent hardware damage. So the attacker can update the wrong firmware to the device, which cause damage to the system. And so what we want to do is we want to also control the permissions and the permissions to the firmware file updates, and also the privilege on who can actually update the firmware. So we want to make sure that we control these areas so that way permanent DOS doesn't occur. And also monitoring your traffic. Physical attack would be someone would attempt to damage the facility or cause equipment damage, and that would be done physically by entering your facility or using the parameter of your facility to cause some kind of damage. When they enter the facility, they can cause equipment damage. So we want to use physical security protection in this sense, where we would have parameters, door locks, fencing, security guards, surveillance camera, and so on. And that will be the next chapter. Another type of attack would be ARP poisoning, in that the attacker would alter your ARP cache. And in the labs throughout the semester, we have explored ARP and ARP table. So in the victim system, ARP table is used to cache information. So for the attacker to attempt this type of attack, ARP cache would then be altered. So that changes the communication that's passed between the victim system to the correct destination, but instead it will be passed to the attacker system. It's often used for man-in-the-middle attack, and so this is a way that they can be intervening in the conversation between the systems. Vlan hopping is an exploit against VLANs, in that individuals or attackers can gain access to VLAN without a connection by double tagging the frames to different VLANs and imitate trunk port. So they really have to analyze your local area network traffic and looking at VLAN in your infrastructure in order to mimic this. So VLAN hopping is often done by people who are aware of your network traffic. So we might look at internal threat, and also we want to look at our network design and how they're able to study our network and visualize our network mapping. Deauthentication is a method that sends command to disconnect or stop client authentication session in the wireless environment, which require the client to re-authenticate, and they would use that to replay the traffic by looking at wireless encryption and be able to try to capture that traffic and looking at how they can authenticate as that client. So deauthentication is a way that they would be able to jeopardize your network, especially in the wireless area, by looking at your actual client authentication session. Compromised system are systems that are being exploited, and a compromised system should be disconnected from the network as soon as we are able to identify the compromised system, whether it's through a threat from like a virus or being attacked. We need to make sure that we disconnect that system physically from the network, simply removing the cable or disable the wireless adapter. Then we need to look at the logs on those systems to be able to see how and when and where that's coming in from. Now, we also need to evaluate the effect of malware on the network, because malware can cause damage to data system and it can spread to other systems. So malware is a type of threat, and that would be introduced externally into the network via email messages or via links, downloads, etc. And some of that we can control through user education and awareness. So, and also configuring the control on the resources, filtering, access, web content, and so on. Some of the threat can be insider threat, and that could be malicious employee, disgruntled employee performing malicious actions, stealing data, committing fraud, and so on. So a lot of this can be controlled via employee screening, evaluation, mandatory vacation, separation of duties, and so on. In other type of attack that's focused on software would be the zero-day attack, in that it would involve the vulnerability of the software that is currently unknown. As software is designed with flaws, and so by evaluating that software as soon as it's released, capitalizing on its vulnerability, that will cause a zero-day attack. So common vulnerabilities that's found on the network are unnecessary running services, so those type of services needs to be disabled. Open ports that are not used, so the attacker can gain access to these ports. So we want to make sure we close these ports, and we want to implement effective firewall rule for our traffic. Unpatched and legacy systems. Legacy system uses old protocols, so keeping the system up to date and patched is very important. On the legacy system, there might be security flaws, so we want to make sure that we isolate these systems on our network and make sure that they are not intervening with our operation or production system. Unencrypted channels, we want to make sure that communication between systems are encrypted to reduce the risk of attacker capturing our traffic. Using protocol analyzer and traffic analyzer, they can listen in and monitor our traffic and take a look at our communication that's unencrypted. With that, they were able to get sensitive data and also potential credential for sessions and communications across the network. Clear text credentials should not be used. Authentication protocol should be applied using encrypted passwords that are stored to prevent escalation of privileges or impersonation of the users. Now, some of the protocols that are used can be unencrypted protocols or unsecure protocols, so we should always implement secure protocols when we adapt application services or using communication. So protocols such as Telnet, HTTP, serial line internet, FTP, TFTP, SNMP version 1 and 2, those are the protocols that we want to stay away from. So if you're using legacy devices, old routers and switches, along with servers, we want to make sure that we look at ways that we can implement controls over those and avoid using the old protocol. So we want to move away from these and gradually upgrade our system to make sure that secure protocols are being used. Tempest RF emanation is a way that the attacker can read radio signal or electrical signal that is being processed for various things, such as door access, communications, and they can use that against the network or to be able to access systems. So sound, vibration, electrical signal, they can use reader to be able to detect that. And so we can use telecommunication electronics material protected from emanations, spurious transmission, which is a Tempest system. This is used to hide signals, and so it will be able to create a shield in that we would protect the signals that's being transmitted, especially on the wireless, the Bluetooth, and so on. Now, another way that you can physically protect signal leaks is using proper antenna angle, also using glass and water fountains to be able to shield some of the signal, and also metal plates and wall if we were able to implement the physical control with that. And some company would use signal jamming on the parameter to be able to control the signal from expanding above the area, especially electrical signal and um, also radio signal. Next, we're going to talk about malware, and malware is a type of software that can cause damage to files or delete files. And the type of malwares are listed. So we will start with worm. Worm is a self-replicating virus. It would infect the system without the user intervention. So virus would require the user to commit to a certain action in order to spread, whereas worm would be self-replicating. And so it will be more vicious than the virus. Trojan is a program that would trick the user into installing the malware by mimicking or masking, or it would masquerade using common files or application. Spyware is a hidden software that monitors and collects information about system activity. And as you can see, most of our browsers are implemented with a type of spyware to be able to listen in and look at our browsing activity for marketing purposes. Adware is a software that loads advertisement on the system, usually for pop-up reasons, and we can control this by using browser security configuration and also anti-malware software tool. Logic bomb is a malware that's activated by a certain event. It could be triggered by date, or it could be triggered by certain logic. So the way that the program is written is it would include a type of logic. And when those logic becomes true, then the malware would be activated. Keylogger is a software that is installed on the hardware to be able to capture keystrokes on the system, and often it would come in the form of USB. Sometimes it would just be software based, where it would be installed on your system using an embedded link, and or on a smartphone device using a text message with an embedded link. So as the user clicked that, it would install the software and it would record every keystroke that's typed on that system and be able to report those keystrokes to a third-party system. Spam is unsolicited commercial email sent to the mass distributed in a certain website for a news group. And sometimes it would be unintentional spamming or intentional spamming. But there are regulations against spam, so we want to be cautious of that and make sure that our users are not committed to or sending spam. Ransomware is a malware that takes control of the system and it demands a type of payment to be able to release system. And often you would see this where they would encrypt the storage drive where the OS cannot load, or it would take hold of the data. And so once the ransomware is activated, you would need to pay a ransom fee to be able to obtain the key to decrypt. However, sometimes even obtaining the key will not work. So most companies would opt out to rebuild the data from the backup, and in that we would lose some data. However, having a payment does not guarantee that you will be able to access your resources again. So to really mitigate the attacks, there are several things that we need to address in our network. First, we need to patch our systems, our OSs, our applications to reduce the potential risk of exploits and attacks. Second, we want to make sure that our traffic is encrypted using encrypted protocols, and also implementing encryption in our services such as email, web, FTP traffic, and so on. We want to also use anti-malware on the network just to be able to do live scan and also regular updates to protect the system from being infected by malware. We want to use strong passwords and educate our user to use complex and strong passwords. We want to train our users on security awareness and practices to make sure that they they use the system securely and be able to make sure that they are not falling into social engineering tactics. We want to use hashing to verify data integrity using algorithm, and the common one that you would see is SHA-1 or MD5. Now on the system security, we want to implement authentication, part of access control, in that we want to validate the user and the systems that are accessing our network resources. So in authentication, under the Microsoft system, we have anonymous authentication, which we want to stay away from, in that no login is required. This is commonly found on public FTP websites, and so we don't want to use anonymous authentication. Basic authentication would allow the user to use username and password, but it is in clear text. So we also want to stay away from basic authentication. And this is what you've seen in the older Windows versions, such as Windows 98. Integrated Windows authentication is higher in security in that username and password are sent to the server in encrypted format. The downside of this is that somebody can capture that and be able to do reverse engineering and be able to guess the password information. Kerberos is our current technology, which requires mutual authentication protocol that's used in our Active Directory, which stores the access information of the user or the system. It uses the KDC, which is Key Distribution Center. It's distributing tickets for the requesting client. So in order for the client to authenticate, it needs to contact the KDC. The KDC is a service of the authentication server that grants ticket to the client system known as the TGT, or the system obtaining that ticket would be ticket granting access. So the example for this is like, the analogy for this would be, if you want to access an amusement park like Disneyland, you have to first show your ID to verify that you are the person that bought the tickets. So once you do that, they would scan your ID and they would give you a wristband, which is a ticket granting service in the server. With that wristband, you will be able to access the amusement park and or certain area of the amusement park. Now, sometimes we would see VIP wristband compared to regular people that would visit the park. So with that, we would see that with granting access or authorizing access based on the type of ticket or the client request ticket. So in this case, in Kerberos, there's a mutual authentication going on between the server and the client itself. In the next part, we will talk about authentication protocol. So we have password authentication protocol, which is known as PAP. This is where credential is stored in plain text. And this is what you would see with basic authentication under the Microsoft system. The second type is Microsoft Challenge Handshake Authentication Protocol, which is your MS chat. This is a variable of chat that uses MD4 hash, which is used in Microsoft point-to-point encryption, or MPPE, to encrypt traffic between the client and the server. MS Chat version 2 is an improvement of version 1, and this is an extended of authentication in both client and server. And lastly, Extensible Authentication Protocol, your EAP. It allows multiple login methods that is used in remote authentication dial-in user service, or RADIUS. This is a centralized authentication service that's used by RAS, Remote Access Server, wireless, or VPN solutions. So currently what we would see is that when you're using remote access, you would use Extensible Authentication Protocol with the Microsoft environment, and also MS Chat version 2 is being used with the authentication for client and server, and also Kerberos. So what you would see here is a diagram that shows you how the client would request a connection with the Radius client, which is then passed to the Radius server through the local area network. It would then authenticate and verify and would then authorize whether the client can be connecting remotely to access the network resource. So the 3 authentication factors, this should be 4, but the book only lists 3. Something you know, something you have, and something you are. Something you know is like PIN and password. Something you have would be your smart card, USB token, email, smartphone. Something you are would be biometrics, your biological characteristics to gain access, such as fingerprint, facial recognition, retina scan, palm print, etc. And the 4th area the book did not mention is something you do, which is a type of action that you can do, like swipe or a certain gesture. And the 5th area would be somewhere you are. That could be a geographical location, that would be pinpointing. So as we bring the device into the physical area of the network, that it would be able to track based on how that device is connecting to the wireless network and based on the geographical location of that device. And so that would be able to authorize some of the access in specific zone or location of our network. Single sign-on is a principle that allows the user to authenticate to the network and be able to have access to multiple applications or resources by using the credential token, which contains the privileges and permissions for our network resources. And so the user does not have to re-authenticate multiple times in that access token is being passed across the APIs to be able to allow the user access. And in the network environment, we want to follow the AAA, authenticate, authorize, and account. So authentication just validate the credentials of the presented user. The authorization is a way we would grant access based on how they authenticate. And accounting is a way that we would log the activities for the usage and the services of that user. Diameter is a protocol that's designed for our Radius server. This allows us to have reliability and scalability using TCP in communication. So in place of the old Radius, protocol Diameter is currently being used for Radius server. TACACS, TACACS, and XTACACS are the control system that authenticate on Unix clients over TCP using and UDP using port 49. Cisco implement XTACACS for their devices for authentication. Later on, upgraded to TACACS Plus, or what they call Terminal Access Control System Plus, which is now a protocol that supports AAA using in Cisco equipment. It is using TCP communication with the topology of the radius for the client network. And often you would see this being implemented with network attached storage. So the difference between permissions and user rights, permission is a level of access to files, folders, or objects on a system in a network, whereas user rights contain privileges with the OS to be able to perform tasks such as installing application, shut down system, change system time, and so on. Now, in Windows environment, there are Windows Security Subsystem, and this subsystem is being implemented for the authentication process. There are multiple components in the subsystem, such as the local security authority or your LSA. This is used to manage your authentication services against the security policy. This is how we would be able to generate token based on our group membership when we log into the system, and it's on the local level. NetLogon service is a way to maintain secure connection to your domain controller. When the user authenticates, the credential needs to be passed through the secure channel in order to log in, and the domain controller would then be able to return the security identifiers which identify the rights of that user on the network. Security Accounts Manager, SAM Manager, is a database file that contains user password. This is often used for users who authenticate locally, remotely, or on the network. It is partially encrypted using syskey function, which applies the hash algorithm to the key, which then is used to store the password of the account. Active Directory is a database that contains users, groups, systems, sites, policies, and for authentication purposes. Security Reference Monitor in the Microsoft environment verify the permissions and rights to access objects. This is used when we implement access control lists and that user is accessing an object such as files and folder on the system or on the network. It would compare what that user is given or granted to what the action of the user is trying to commit on that system. WinLogon is an interface. When the user press Ctrl-Alt-Delete, it would be the service that prompt the dialog box for the user to type in their username and password. So the logon process consists of the following steps. First, when the user press Ctrl-Alt-Delete, WinLogon presents the dialog box. Then the user would type in the username and password. Next, the third step, LSA would make the call to the authentication package, which is passed to NetLogon service. Then NetLogon would compare the username and password to the SAM database. This is where it would match up your password to what is stored. NetLogon provides security identifier if the password is matched, and then it would check with the LSA to be able to find the group membership which grant your permissions and privileges. So LSA generates an access token which contains the user rights and group membership. That access token would then be associated with that user account to certain resources based on the rules that are set for the groups and the permissions that are set for objects for that particular user based on group membership or the user account in the network. So here shows the diagram of all the steps. Now, when you implement Kerberos, it's a little bit different than what we've seen in just your regular authentication process. In Kerberos, it would use Active Directory in which the user needs to log on to the network. So the first two steps is the same. Ctrl-Delete is pressed. Then WinLogon would present the dialog box. The user would then type in the username and password. Logon credential is passed to LSA to determine. Now, at this point, it would require the DNS domain controller to authenticate the user instead of the system itself. Now, then after that, the LSA would contact KDC, which is Key Distribution Center, on the domain controller to request a session ticket. And Kerberos would then contact Active Directory to authenticate the user by retrieving the group membership based on what is set for that user account in the global catalog server. So when you create the user group in your lab, you would see this where we would select, right, the type of group, and that would be the hierarchy in how that user is accessing at which level of our network. So once Kerberos retrieved the group membership from the global catalog, it would then determine and send the session ticket that contain a SID or the security ID, which is a list, a string of numbers that would tie the user group memberships to what they can access on the network. So that session ticket would then be sent from the server to the actual system, and it would be able to construct access token on the local system based on the session ticket that's assigned from the server. So here, this is where the user would then be able to access certain resources or denied of a certain resource on the network. So in the access token, it contains the following components. SID, which is security ID. This is a unique number that's assigned to the user, and it would be specific to that user account, also linked to the group membership. Group security identifiers would contain the groups that user belongs to, because there are group access rights and permissions are tied to group membership, which is stored in the group security identifier. Then you also have primary group security identifier, which is for Unix system. This is for POSIX compliance, and it would identify the primary group that would be specified for the user and what files they own. Access rights would be contained in the access token pertaining to the actions that user can perform on the system. It would have the list of rights that are associated with that user account. In the next part, we're going to talk about access control and security descriptor. So access control would contain a list of user groups and their relevant or associated access to objects based on what's granted, permissions that's granted. Each of the item on that list is considered an access control entry or an ACE, which contains a user or a group or an object. Security Access Control List, your SACL, would contain the auditing entries of the object that has been enabled. So comparing to an ACL to the security ACL is an auditing entry. And auditing is when we go back and review the type of access that was committed, compared to access control list, which is just simply a list of user groups, objects, and their associated access permission. Discretionary access control list, your DACL, would determine the users in a group that have specific level access to a certain object. So in the diagram here, it shows you the security descriptor, and we would start with the primary group ID, the ownership, which is the SID would then associate with what type of object that user would own. Then it would have the list to audit the entry and decide whether the user have permission to certain object. And then lastly, DACL would be a list of permission that determine who has access to a certain object on the network. So with that, all the components would be part of security descriptor for the user or the group or the object in the network. Now, permission control in Windows environment, if you are if you're using new technology file system, and you will be able to access object property sheet, which is where you would right click the object such as files and folder and click on security tab, you would be able to see the type of access the user is granted. So the access permission would be list the folder content, where we would be able to see what's in that folder, read to be able to view a specific file or view that folder. Read and execute. This allows you to view and run executable file or execute a program. Write is where it would allow the user to modify the content or create a new file in that folder. Modify is the permission that include all the other permissions, including modify. But the difference between modify and write in that modify allows the user to delete. Full control is where it would include all the permissions that are listed in the access control list. Special permissions is any permissions that are preceding the list, and it allows the administrator to customize the permission in addition to what is listed on the ACLs. Now, permission control is very important in registry because registry is a database for all the users for computer settings, software, and the system settings. So we want to make sure that we protect the actual container or folder where the registry is stored. And you can find this in system root, system32 config folder. And there are various sub directory under that. So you want to make sure that the parent directory, you need to control the permissions on who has access and who's denied of access in that. To configure user rights in Windows operating system, you would then refer to user rights assignments under local policy. And you can find this on the domain, the default domain policy. So very much like one of the lab that we did with remote access, we use group policy management console. So in that, you would be able to find the default domain policy and use group policy object editor, group policy editor in order to modify the actual user rights assignment under the local policy. And after that, we would need to enforce the policy once we modify it. So it would carry out the user rights assignment, such as login for the user at a certain time, or allowing them or disallow them from wireless connection. Configure auditing policy is also essential, and auditing policy pertains to looking at activities that would be suspicious, such as accessing files and folders, log on to a certain part of the network. So we can audit successful and failed events. So if we're looking at login, successful event would be that the user successfully log in and authenticate to the network. The failed events would then help us track the attempts for the user, whether they're using a wrong password or someone is brute forcing their password. In monitoring logs, we can look at a centralized repository of our logs, and in Windows environment, we would use Event Viewer. We can look at security events and audit those. So to implement security on the network, some of the areas that we need to look at would be controlling traffic that's entering and leaving your network by configuring your firewall rules or your router. Second, we can use network access control to manage wired and wireless connection by assessing posture or the health of the systems that are connecting to our network. They have to have anti-malware, they have to have patches, and so on. So we can have a way to control, and if they don't meet the requirement, we can deny the access to our network. We can set terms and conditions for wireless access. They must agree to the terms and the conditions. We can patch the status or the systems that are being accessed and the clients that are connecting. Switch connections we would require the client to authenticate when they plug into our switch. So, and only we would control the privilege based on that. We can set port security, disable unused port, filter port connection, and also MAC addresses. So we can associate MAC with the port, and that way only specific system can be connecting to that physical port. Network segmentation, we can separate and manage data segregation using firewall, VLANs, and physical connection. So we can adapt switches and be able to connect to the switch. We can configure VLANs to the switch. We can filter with firewall, and for VLANs, automatically when you're on the VLAN, you're not, by default, you're not able to connect to other VLANs. So in order to connect, we would then have to pass the traffic through the router and also the firewall. So that would just put additional gates or control for intrusions that would already be inside the network. So we want to make sure that we also implement intrusion detection system, intrusion prevention system, and also design our network in that it would be harder for them to reach sensitive data. Then we can implement supervisory control and data acquisition, SCADA system to monitor operation, especially for the industrial environment. Such as HVAC, for the physical security, power availability or power distribution from in the plant, and so on. So SCADA system is really able to manage buildings, facilities, controlling resources for operations, machinery, and so on. We would separate legacy system from the network to reduce vulnerability on the network. And we want to separate private and public networks using DMZ. Honeypot and HoneyNet should be on a segregated segment network, and on that we would not put production system. And so Honeypot and HoneyNet are used to lure attacker to a certain area of network to either study their behavior and also to remove them from the production in case they are jeopardizing their network. Testing lab should not use the same IP or system information as your operating system because that can cause conflict. So we want to also make sure that those are separated from the rest of the network. Performance optimization and load balancing is really important. That will prevent bottleneck. And also we want to consider using separate switches for different floors, different buildings, and be able to control the load by balancing it across the servers and our appliances. Control system and user access in multiple segments of our VLANs. And so we can isolate the VLANs, or we can allow specific system only to connect across the VLANs, but usually we want to use VLANs to segregate different segments of our network. We also want to follow compliance requirements, especially when we are protecting sensitive data through network segmentations and implementing filtering rules and block to be able to accomplish this. Then the last two things would be set firewall rules based on IP address, MAC address, port, and protocols, especially for inbound and outbound traffic. And we want to use encrypted communication to protect our traffic and data transmission. Now in encryption, there are two types of encryption that uses two types of keys, symmetric key encryption and asymmetric key encryption. There are two type of encryption methods, actually three. Stream cipher, which is to encrypt one bit at a time. It is faster and it's often used for the web and email or data on the move. Block cipher is used to encrypt data in block. It requires more overhead, meaning CPU, processing, and RAM and resources, like bandwidth. So block cipher is often used for something that's highly secure because it requires more resources. Padding in that we would use padding to add to the block cipher to complete the data stream. So in this, you would see two types of methods, and padding would be piggybacking on the block cipher algorithm. For encryption standards, these are only a few of the common ones. So you have Data Encryption Standards, your DES. This is a 64-bit block cipher, and it uses X392 and X3106 standards. It generates random key, which are symmetric and 56-bit for each block. Triple DES it uses three mathematical operations compared to the DES, which uses a single mathematic operation. It is a block cipher using 56-bit keys to create 168-bit encryption. Advanced Encryption Standard is an improvement or replacement of 3DES. It is a block cipher that supports 128, 192, and 256-bit encryption. AES is currently one of the best for the block cipher for most of our portable devices and also our wireless technology. Ron Rivas, Adi Shamir, and Leonard Alderman, which is your RSA. This is used the PKI infrastructure or the public key encryption, which randomly generate prime numbers to derive another prime number for no pattern private key. So the public key is generated by prime numbers, and to derive the next key, which is your private key. And public key would, if you use public key to encrypt, private key would then needs to be used for decryption. So RSA is used in pretty good privacy, and a lot of different things is what you see in Linux system now uses RSA for SSH session. Digital signature is used to verify the sender and the receiver communication. It is a way for our trusted application to validate signature and use certificate authority that stores public key for the user to certify that the person who signs, the person who sends that data is the correct individual. So it validates that. It is important to really encrypt the communication data in the network to use secure protocols such as IPsec, SSL, TLS, L2TP, HTTPS, Kerberos, and WPA2. So even with signature and some of the data encryption technology, we would see that when we transmit that, we still have to encrypt. And encryption does require overhead, so you have to plan your resource accordingly. Now, in network, we want to make sure our connection is fault tolerant. That means that we ensure that our system is always functioning, and we would derive solutions to backup power supply, storage, network links. Our goal is to mitigate a single point failure, and so we want to achieve high availability on the network, which is the 999.9999%. Now, to implement solutions, we can consider RAID, which store data on RAID drives and manage the drives through OS controller. We can also implement network link to have secondary network link, an alternate connection to WAN. Our critical nodes and assets should should be clustering or have failover cluster to make sure that in the case that it fails, we have a secondary system as backup. We want to have redundancy to our network design and our system in that critical components would have secondary backup options in the case the primary fails. So the high availability is our goal in managing and deriving solutions for our network. We would use load balancing, NIC teaming, port aggregation, and failover clusters to be able to derive that along with power management. So in power management, we simply would use UPS generators, dual power supplies as a backup power source in case there's power failure. With disaster recovery, you need to make sure that we have a plan for backup, restore, and the contact of our vendors and the decision makers or successor in our disaster recovery plan. The backup and restore strategies basically would just be a step-by-step procedure on and the type of methods that you would use for backup and restore. So we can have snapshots, which allows us to recover from the configuration of our system in case of change error or failure. We would have offsite storage to store our backup for either backup drives, or we can do cloud offsite for data storage. Now, backups can be hot or cold spares. The backup devices, when it's hot, it would be that it would be connected to the power. In the case of malfunctioning and failure, it would be used. Cold spares, it's not connected to power and it would replace primary device in the case of failure. You can also have locations for backup, hot, cold, and warm sites, and now we would also see mobile sites. So these are alternate locations where a company can move their operations to in case of emergency. The cold sites would contain space, network, systems, software in the case of disaster. So that means that the cost for the hot site would be more than the cold site. So the hot site would have the full-blown network with the systems. The cold site doesn't have any type of system, so you have to rebuild the system in the case that it happens. So it costs a lot less, and that it would only have the space. Warm site would have some spare equipment, such as some backup servers, and you would need to fully reestablish. So warm site would cost a little bit more than the cold site, but less than the hot site. Some of the terminology that you would see on Network Plus and also on Security Plus is your mean time to restore. This is the average time for the system or device to recover from the failure. So if it takes you 8 hours to recover that server last month and it took you 6 hours to recover that server this month, you simply just take the average time for the recovery for that server. So 14 divided by 2, so the average would be 7 hours. The mean time to restore is the average time for the system to recover from the recover. We said that. Mean time between failures is the amount of time between failures for the system and the device. So if the server normally fails every year, then the amount of time between failure is 1 year. The mean time to failure, so that would be the amount of time for the device that is expected last before it fails. So the difference between the mean time to failure and the mean time between failures is that the mean time between failures talk about the uptime, and the mean time to failure is the amount of time that is expected to last before it fails. So you can have a system that would fail every year. So the between failures would be yearly. Now the mean time to failure for that system should expect to last before it fails. That will be less than 1 year. The recover time objective, your RTO, is the amount of time allowable between business functions that must restore after the failure. So the outage can be 8 hours when a certain system fails. So the business would then not be able to function between the 8 hours. So your recovery time objective would be the 8 hours. The recovery point objective would be how much of the system is expected to be recovered. And here we would want to say, 24 hours from the last backup. So we did lose some data, about a day of data after the last backup. So we would then have to restore to the last backup and rebuild some of the data for the last 24 hours. SLA agreement would be the level of service that's agreed for the company to provide a certain service. And this is what you see with internet service provider, cloud service provider, and even communication or phone company service provider, and so on. So that SLA is really important because in the case of emergency, you have to go back and see if they're able to help in recovering the data, or are they able to secure some of your systems, and so on. Now, the guidelines to protect the network, we wanted to protect physical security, fencing, door locks, entrance logs, CMOS settings, servers, access, and so on, and even implementing security guards and surveillance. Firewall, we want to filter for our traffic based on IP port protocols and MAC address. We want to implement intrusion detection system, whether it's host-based and network-based, to be able to analyze traffic based on signature files or anomaly or heuristic. Now, host-based would be in the software installing for that system, and network-based would be the software or appliance that's installed on the network. And network-based is on a larger scale, so we want to make sure that the system is monitoring all the connected system on our network. Your passive IDS does not take actions against detected services. It's simply an alarm system. Your IPS would block the intrusion activities based on signature, heuristic, or anomaly. So IPS, the difference between IPS and IDS, and that IPS prevents, where it is active. It is an active system in that it scans and blocks, whereas IDS is more passive. Honeypot and HoneyNet, we touched on this before, but we want to make sure that high-level logging is implemented to track activities of that part of the network for security reasons, and also learn about the attacker activities. Policy and procedures, which would be used to make sure that people practicing security and we're configuring and adhering to compliance. So some of the policy would be acceptable use policy, what's allowed and not allowed for systems and network, password, incident response, firewall, and so on. There are many different type of policies, and in the security classes, what you would see is that policies can be written and established, so that way we would then follow that up with the configuration. Here it talks about system life cycle. We wanted to follow the cycle to make sure how system is being integrated, and also at the beginning of life and also the end of life on how it will be disposed. We want to follow safety procedures. We want to have SLA, MOU, MSA, and state of work agree. So state of work, you would normally find this with contractors, could be yourself, where it would state the deliverables, the time frame, and what type of work will be achieved. Non-disclosure agreement, a lot of companies, because you work with sensitive data, you would often be asked to sign an NDA, which require that you keep the company proprietary information confidential and not share that with entity that's outside of the organization. Data breach is an event where sensitive information is disclosed to an external party unintentionally or intentionally. And in the case of the breach, the first responder would be trained to handle the incident and containing the breach by either disconnecting the system or removing or blocking a certain type of traffic from breaching your data. Vulnerability testing and pen testing is often used in the network environment. Vulnerability testing allows you to identify the vulnerability in the network, the weakness, and you can use MBSA, Microsoft Baseline Security Analyzer, which is now part of the suite, Tenable Nessus, LandGuard, and other tools. Pen testing is a way that we would test security system by using active security tools and attack tactics. And normally we want to get permission to do these things and not do it on our own will. Security awareness training, there would be many methods to be able to implement this, including lunch and learn, intra-site for training delivery online, awareness seminars, training courses, and so on. In the next chapter, it basically reviews most of the things we talked about in physical security. In addition, it talks about access control that we touch on with using 802.1 for control standards to grant access, using NAC, port security, MAC filtering, ACLs, cryptography, and so on. Now, some of the areas that we didn't touch on is the guest network and quarantine network. Guest network should be separate from your production network to really reduce security risk. And guest network is often public facing in that you will allow the public to be able to access that. It could be on the wireless side. So we want to make sure that we would separate this network and not have any kind of system that will hold sensitive data be connected to this part of the network. Quarantine network would be a temporary location of the network where if the client doesn't meet the requirement, they would be placed here to make sure that they are either updating, patching, installing anti-malware to be able to meet the requirement before they connect. Edge versus access control, we wanted to place the security checks at the edge of the network before we grant access to our network. We can use switchport security with inspect ARP, filter MAC address, and also look at assign VLAN to a specific ports. Disable unnecessary services, ports, and devices. We can also web filter and content filter using URL and keywords. And we saw this when we did the last lab 13 for VPN. And we can implement firewall. And here it goes into different areas of the firewall, like the type of firewall, software versus hardware firewall. Software is just an application that you install that would be host-based. And then hardware firewall would be an appliance. We can implement this for our small or even large network. And stateful compared to stateless firewall, stateful inspects packets for filtering, and stateless does not. And UTM is the Unified Threat Management that contains security features such as VPN, firewall, IPS, IDS. And we saw this when we look at the VPN router in our lab, where we have an all-in-one devices where it's able to filter, control, detect, and so on. Dual home host firewall is a single computer or a system that can be interfacing the gateway between the networks. So here you would see the firewall that's going to interface between the service provider network, which is what represents the cloud, the internet, and also our local area network. So we can permit certain type of traffic based on ports or protocol as the diagram shows. The screen host firewall is the screening router that's placed between the dual home firewall and the public network. So this is often seen as an external firewall. That means that it is at the edge of our network before, so it would be a screening router. So it would filter, but it is acting as a router so the traffic would hit the screening router before it gets routed into our network. Screening host firewall would then be placed after the screening router, and that would be between the dual home firewall and the public network, and this is where it would screen the traffic. The screening subnet firewall would then be placed in the internal network, and that would be after the firewall and after the router. So this is considered to be a router after the firewall, so that way it would be able to separate traffic to a certain area of our network. And so the type of firewall you would see packet filtering. This would inspect the IP, the port rules based on the packet. Stateful packet inspection, it would be inspecting traffic based on source and destination addresses or port numbers. Application level firewall, that would inspect data of the application. Circuit level firewall, it would operate based on the communication channel and circuits. NAT, PAT, caching, and proxy servers can be considered filtering systems that would act like a firewall. So in the zone and firewall placement, we would have three areas. Private zone, where the firewall is placed in front of the LAN to create a private zone. So this is before the local area network at the edge. In the DMZ, so two firewalls would allow the traffic from the public to be in a zone. So one firewall is going to screen the web traffic. Second firewall is going to block that traffic from coming into the network or filter it. Public zone is where the internet or external network, which is not controlled by our local network administrator. Port filtering, we can set up for a certain port to be filtered. IP and port filtering is used in packet header. We can have direction of transfer where inbound and outbound filtering can be used. Source and destination address, we can filter packets based on where that's coming from or where it's going to. And virtual and routed, we would use transparent firewall, it would inspect the traffic and block based on web SMTP filter without altering the address information. So to mitigate a lot of the security problem in our network, we can manage signature or updates of our IDS, IPS, and anti-malware. We would have device hardening by doing switch port protection, using spanning tree, change native LAN information, enable bridge control, protocol data unit guard, enable flood guard, root guard, and DHCP snooping. We can also have network segmentation to control how across the network how the systems are communicating. If we want to prevent certain system from communicating from one segment to another, we can do that. We can set up DMZ in that system will be able to be accessed by other networks like the internet. So if you have web server, you can put that onto the DMZ, where we can also implement VLAN to set up boundaries internally in our local area network by setting up the ports to the switch and also group those systems onto the virtual local area network. We can manage the privilege for the user account, look at file integrity using hash, having role separation. We don't want to give one person all the roles. We want to be able to separate the duties for the individual in case to prevent fraud. We want to restrict using access control, and access control lists can be used on Firewall or even on our systems for file folders and object access. And we can also use pen tests to evaluate our security configuration and looking at how that would scale in the landscape and how we can improve our security landscape over time. So in 16, it talks about monitoring. In monitoring, we can use Snmp to be able to remotely connect. So if you took CIS30B with me, you probably heard about Snmp, where we actually wrote script to be able to manage our network devices. So in Snmp, we have management information base, which is your MIB. It defines the type of objects that can be retrieved from the device, such as object ID. So using SMMP, it would have three types of messages. Trap, which is a message that the agent would notify the manager. So you might have like a Linux server that access an agent to be able to queue or inquire information about other network devices. And we would use this for inventory and monitoring purposes. We would have a get message to retrieve the information of the enabled device. So if you want all the Cisco routers information or like the iOS on those Cisco routers, we can use get message. The third type of message is called walk, and this is used to retrieve the hierarchical information. Unlike get, it would have different higher level of information that is, especially if you have an enterprise type of network, you would use walk. Syslog would use to be able to send messages to the syslog server, which stores the information on errors, warnings, system information. We can also view history logs, which are past log files, and we want to manage this so that way it would not be excessively large. So our capacity would be able to be met due to costs and maintenance reasons. We can also analyze traffic, general logs, and use Network Sniffer to determine our network performance and health. Now, for Windows logging, you would find most of the logs exist in C Windows System 32 log files. And you can also look at audit logs under C Windows System 32 config folder. In Linux system, you can find this under var log and messages for your system files. And for the last log file, it's under last log under var log directories. So scanning ports, assessing vulnerability, managing patches, fixes, and reviewing baselines is really important in monitoring. We also need to monitor system performance, processes, and hardware usage, because if storage fails, if RAM fails, your server will fail. And if your server will fail, that would reduce the availability of your services, and that can cause issues on your network. Some of the network monitoring tool, you can use Performance Monitor, Resource Monitor, and Network Monitor. Those are considered interface monitoring tools. You can use Top Talkers and Listeners, such as NetFlow for Cisco, which listens to traffic, and this is useful for denial of service attack. Packet flow monitoring is used to evaluate transmitting packets by looking at routing table, and access control list. So if you wanted to take a look at where your traffic is being routed and what type of permissions in a certain area. This is going to packet flow monitoring would be used. In event management, we can use a system such as SIEM or SIEM, which is a centralized software for security information event management system. This allows us to look at notifications. Those are just information about our events, alerts, which would be where a certain event is reaching threshold or a certain boundary. And so we want to be able to manage this and categorize them. So the critical alerts needs to be addressed first. Environment and power monitoring is also very important because power outage will cause our system to not be able to function. So we want to make sure that we monitor our power usage on our system and making sure adequate power supply is there. Humidity is also important, and temperature control. So we want to make sure that there's low humidity and low temperature is adequate for our server system in our closets. For best practices in monitoring, we want to look at baseline, which capture our normal conditions and how our usage and performance would be in case of issues. We want to look at bottleneck for processor, bandwidth, memory usage, and to manage the overutilization of our resources. Log management allows us to detect changes and issues in performance and bandwidth. Splunk is a good tool for log analysis. Graphing is a way to visualize performance based on the reports to really understand goals and based on how our current performance level. We would monitor utilization of our bandwidth, storage, network, CPU, and network device memory. Some of the metrics that would be used when you're monitoring interface, and when we're talking interface, that will be your network interface, would be error rate, utilization percentage, packet drops, bandwidth and throughput, link status, such as your LED blink lights, interface resets, the counters that is tracking the packets that are sent, dropped, and error, and then the speed, which is your duplex. And so when we look at the speed, we want to make sure that we check to see if it matches the communication channel. We can also use Snmp tools, which we just covered, to monitor speed of routers, switches, servers, using applications like Cacti or MRTG. And this concludes the last chapter in the book, and also the last unit, which is unit 13. And in this, we talk about security practices, and our network monitoring and management practices. And thank you for watching this video.